Hi there, my name is Denny Lee. I'm a Senior Program Manager with the SQL Server Customer Advisory Team, Microsoft. Measuring and understanding the performance of your SSIS packages in the enterprise is today's video. And this is the first of 4 videos which will cover SSIS Designing and Tuning for Performance, SQL Server video series. We will also be talking about tuning your SSIS package data flow in the enterprise, understanding SSIS buffers, and designing your SSIS packages for parallelism. In today's video, you will learn how to measure and understand the performance of your packages. These are based on lessons learned from enterprise customers. Review what is important and what to measure, as well as understanding the limits of your source system. There's also the importance of disk I/O and then therefore altogether baselining your package. The source and target systems have a significant impact on the performance of your SSIS package. After all, SSIS can only read as fast as the source system can provide the data. It can also only write as fast as the target system can go ahead and write the data. It's all impacted by CPU, memory, network, and disk I/O. Stating the obvious, all the data flows extracted are from somewhere, and you're going to put it somewhere else. You cannot transform it faster than you can read it or write it. So before you start tuning, measure the extract speed of your source. Significant gains can be made from simple things like better drivers, better driver configurations, I/O, and network optimization. Understand these limits early in your design, so that way you can ensure your SSIS packages are optimized for your systems. So we'll quickly measure the performance of our source systems by creating a simple SSIS package to measure row counts. And we'll actually compare 2 different source systems now. So looking at this SSIS package, it's a very simple package. The first thing we have is a simple execute SQL task. It's actually executing a DBCC drop clean buffers at the SQL Server, so that way it's a repeatable test. Within data flow task, we're running 2 data flows that will extract data from a SQL database, and we'll do 2 different row counts. The OLEDB data source, you'll notice, is simply a select statement from a particular table for the month of January in this case, because the data is also partitioned by month. So for this first one, it'll be looking at the data for January, and for the second one, it'll be looking for the data for December. So let's run the package. Now, running the package, you'll note quickly it's running through and trying to do the row counts. And it's relatively fast, but it's also could be run faster. If you look at the Windows Task Manager, we open this up, you notice that the CPUs are going through the roof, but they're not quite being pegged, and memory is not actually an issue here as well. So what this indicates is that there may be some other limiting factor that's slowing the speed of your source system. Since CPU and memory may not be the issue here, then there could be something else. And in this case, we'll find out later, it's actually the disk I/O that's actually slowing down the system. So it's finishing up its counts right now. There are approximately 4 million rows that these 2 different data flows are going to be counting. All right, and they're finishing up now. Perfect. Okay, now if we look at the progress, minimize it, zoom in, you notice that it took 1 minute and 3 seconds for it to finish doing the row count of these 2 tables. Well, these 2 partitions of a SQL table. Okay, well that's good. But if I go to a different source system, which is much faster, you'll notice it has the exact same package, and I run the package again. So in this case, I'll run it now. You'll notice that it's running a lot faster. Now, admittedly enough, this system has a lot more CPUs and a lot more memory to work with, okay? But at the same time, you'll also notice that CPU and memory are not limiting factors for the system. Okay, you look at the progress, minimize. and you'll notice that it finishes in 16 seconds. Okay, that's great. Well, what this means is that I've got an initial source system that took a minute, which is approximately 67,000 rows per second, while I have my other system, which is able to process the data in 16 seconds, which is about approximately 237,000 rows per second. Much higher number. Now, what could be the factors? Well, if we were to look at the perfmon, you'll notice the fact that CPU, which is in blue, while very high, is actually not pegged. So it's not the limiting factor. The other small blue line here is memory. It's also not being pegged very hard, so it's not a limiting factor. But the red line that we see here, that's the average disk second transfer number. That's pretty high, actually. Actually, if we're to go ahead and zoom in a little bit on the numbers here, you notice that the average value is 70, while the maximum value is 243. Now, for people who normally work with disk I/O systems, a number that's higher than 10 indicates that the disk is a limiting factor. That's what could be slowing down your performance. Okay? Well, this is 70, so we know that this particular source system has a very slow disk. Okay? When we go back to the faster source system and open up the performance monitor, you'll notice that the average disk second transfer is 3 instead. So in this case, disk was not a factor for you, but the other source system, it was. Okay. Why is this information important? Well, this information is important because SSIS is very dependent on the underlying infrastructure to improve performance. Things like memory and CPU are pretty obvious and pretty straightforward, so that's great. But disk itself also is a very important factor on improving performance. Okay, so what you'll want to do when you're trying to ensure the speed of your source systems or your target systems is to have very good performance counters, like the ones listed here, okay, and work with your systems engineering team to ensure that the systems are optimal. So if you look at memory, okay, or network interface, you'll notice the fact that in this case, these packages, those performance counters are not being pushed very hard. So you're not worried about memory or network interface. You look at process, like percent processor time or private bytes or working set. Again, same idea. They're not being pushed very hard, not very high. So again, you're not terribly worried about them. SQL Server memory and SSIS buffer spooled, those are important numbers. By the way, for that last point, the buffer spooled, if that number is above 0, that means SSIS is no longer transforming its data in memory, and it's writing to disk to perform its task. That's a very bad thing, so you want to make sure that that number does stay 0. So in the case of this system, the logical disk, no problem at all. It has a value of 3 for the average disk second transfer, so you know that this system is actually perfectly fine. It's very well tuned for whatever your SSIS packages are running. Well, in this particular SSIS package is running. Okay, but if I was to go back to this other source system, flip over to the report, you'll notice that it has the value of 70. This is something that you can go to your systems engineering team and say, hey, I need help to improve the source system so that way we can ensure the SSIS packages can run faster. Another way of showcasing this is to actually look at SQL I/O. SQL I/O is a very handy tool. There's actually a pre-deployment I/O best practices, which is a very good white paper that explains how I/O works. Well, if you look at this, you notice that the SQL I/O test, it actually goes ahead and notes the fact that I have 7,600 IOs per second and 59 megabytes per second. Okay, that's what this system is. But if I was to go ahead and look at the SQL I/O on my more powerful system, the I/O is 12,217.97 IOs per second, and the megabytes per second is much higher at 763.62 megabytes per second. So both the perfmon counters and something like SQL I/O, these are counters and information that you can go ahead and bring back to your systems engineering or infrastructure team so they know how to help optimize the hardware so for your SSIS packages to run that much faster. Okay, back to the slide deck now. Here's the list of the performance counters that you care about. We've already listed them inside Perfmon. They're also here, and they're also going to be in the slide deck that'll be with this particular video. So this is very handy for you guys to use. Okay. The conclusion here is that there's a huge impact of your source and target systems on SSIS performance. You typically focus on memory and CPU network, but you also need to focus on disk I/O, and that's what we've talked a little bit more about today, because this will actually have a huge impact on how fast SSIS can read or SSIS can write. Okay, we have the list of counters for you, as noted in the previous slide, but if you can tune your SSIS properly and tune the hardware around it properly, you can actually achieve some great performance with SSIS. A good example is the ETL world record, in which they were able to process more than 1 terabyte of data in under 30 minutes. There were optimizations to hardware, optimizations to SQL partitioning, things like that, which you can refer to this blog to find out exactly what they did. But the key here is that they had to go ahead and measure the source system and baseline the package and measure what SSIS was doing by looking at these counters so they could understand what was slowing down the package. You can also review more information in the next 3 SSIS Designing and Tuning for Performance SQL videos. Okay? And also check out SQLcat.com for SSIS lessons learned and best practices from enterprise customers. Well, that's it for today's video.